Welcome to a modern industrial facility where agricultural waste transforms into a revolutionary solution for feminine hygiene.
Billions of plastic sanitary pads fill landfills annually, taking hundreds of years to decompose and harming nature.
This factory offers a sustainable alternative by using banana stems, a byproduct usually discarded by fruit farmers.
Banana plants only fruit once, leaving behind a massive pseudostem that farmers typically chop down and waste. Instead of rotting in fields, these stems are collected and brought here to be given a new life. Trucks arrive at the receiving bay, loaded high with fresh green banana stems gathered from local plantations. Workers unload the stems manually, inspecting each one to ensure it is healthy and free from disease.
The stems are sorted by thickness and length, organizing the raw material for the extraction machinery ahead.
The first processing step involves splitting the thick stems longitudinally to access the internal layers more easily. Workers peel away the tough outer green skin, which is too hard and fibrous for soft sanitary pads. Inside, we find the sheaths, layer upon layer of white, water-filled, fleshy material rich in strong fibers. These white sheaths are fed into a mechanical fiber extractor, a machine designed to crush and scrape.
The machine compresses the sheath, squeezing out the water and sap while retaining the long, tough fibers.
A stream of nutrient-rich liquid flows out, which is collected and returned to farmers as organic fertilizer. What remains is a raw, coarse fiber that looks like tangled hair, still wet and slightly sticky.
This raw fiber is submerged in large washing tanks to remove the natural plant sugars and sap.
Agitators swirl the water gently, cleaning the fibers without damaging their structure or tangling them too severely. The clean fiber is lifted out and sent to a centrifuge to spin out the excess water.
Workers spread the damp fiber onto large wire racks, placing them in the sun or drying ovens.
Drying is crucial to prevent mold growth and to prepare the fiber for the next mechanical stage. Once dried, the fiber bundles are stiff and rough, requiring further processing to become soft and absorbent. The dried fiber enters a chopping machine, which cuts the long strands into short, uniform lengths quickly. These short fibers are known as staple fibers, the primary building block for the absorbent pulp core. We verify the length of the chopped fiber, ensuring consistency before it enters the chemical treatment phase.
The chopped fiber is loaded into a large stainless steel digester for the delignification cooking process.
Lignin is the natural glue that makes plant fibers stiff, so it must be removed for softness.
The digester cooks the fiber in a mild, eco-friendly solution, breaking down the bonds between the cells.
Steam pressure builds inside the vessel, accelerating the breakdown of the tough plant material into soft pulp.
After cooking, the brown pulp is discharged and washed extensively to remove the dissolved lignin and chemicals.
The pulp is now soft but dark in color, requiring bleaching to meet strict consumer hygiene expectations.
We use a total chlorine-free bleaching method, utilizing hydrogen peroxide to whiten the fibers safely.
This method ensures no harmful dioxins are released into the environment, unlike traditional chlorine bleaching processes used elsewhere. The result is a fluffy, snow-white pulp that is highly absorbent, sterile, and safe for skin contact. This banana pulp is pumped onto a moving mesh screen, forming a continuous wet mat of fiber. Vacuum suction pulls water out from below, while heavy rollers press the mat from above to compress. The compressed sheet travels through a steam-heated drying cylinder, evaporating the remaining moisture from the fiber web. What emerges is a roll of dry, absorbent paper-like material, made entirely from the discarded banana stems.
These jumbo rolls of banana fiber core are transported to the sanitary pad assembly line for conversion.
The assembly machine is a complex series of rollers and sensors, combining multiple materials at high speed.
At the start of the line, the roll of banana fiber core is fed into the machine.
A hammer mill pulverizes the sheet into loose fluff, increasing the surface area for maximum fluid absorption. This fluff is molded into the core shape, thicker in the center where absorption is needed most. A biodegradable bottom sheet is unrolled, providing the leak-proof barrier that protects clothing from any staining. This barrier film is made from cornstarch or other plant starches, ensuring it composts fully later.
The molded banana fluff core is placed precisely onto the moving bottom sheet by a vacuum drum.
A specialized transfer layer is added on top of the core to distribute fluid evenly across it. This prevents the liquid from pooling in one spot, maximizing the efficiency of the banana fiber core.
The final top layer is applied, a soft sheet of organic cotton or bamboo for skin comfort. The 3 layers, bottom, core, and top, are pressed together as they move through the bonding station.
Ultrasonic rollers weld the edges of the pad, sealing the layers together without using any toxic glues. The seal pattern also creates channels that help guide the fluid toward the center of the pad.
Next, the continuous strip of pads moves to the die-cutting station to create the final winged shape. A rotating blade cuts the outline of the pad, removing the excess material from the edges cleanly.
The waste trim is instantly sucked away by a vacuum system to be recycled back into pulp. Now shaped, the pads are separated on the conveyor belt, spacing them out for the folding process. An adhesive applicator sprays a thin layer of non-toxic glue onto the back of the sanitary pad. A strip of release paper is applied over the glue to protect it until the user is ready.
Mechanical fingers fold the wings of the pad inward, laying them flat against the soft top sheet.
The entire pad is then tri-folded, making it compact and easy to carry in a pocket. The entire pad is dense yet compact.
A biodegradable wrapper film encloses the folded pad, sealing it to maintain hygiene during storage and transport.
The wrapped pads pass through a metal detector to ensure no machine parts have contaminated the product. A vision system photographs every package, rejecting any that are misaligned or not sealed completely tight. Rejected pads are pushed into a separate bin for inspection, ensuring 0 defects reach the final consumer.
We pause the line to take random samples to the quality control laboratory for rigorous performance testing.
In the lab, a technician places a pad on a glass table to test its absorption speed.
Measured synthetic fluid is poured onto the center of the pad, simulating real-world usage conditions and flow.
The banana fiber core absorbs the liquid almost instantly, pulling it away from the surface very quickly. We measure the re-wet value, checking if any liquid surfaces when pressure is applied to the pad. A heavy weight is placed on the wet pad, simulating the pressure of sitting or walking around.
The surface remains dry, proving the banana fiber locks moisture in effectively, preventing leaks and skin irritation. Another test measures the biodegradability of the pad by burying it in soil and monitoring decomposition.
Unlike plastic pads, which last centuries, these banana fiber pads decompose within 6 months in compost conditions. Back on the factory floor, the production line continues at high speed, producing hundreds of pads per minute. The wrapped pads are gathered into groups of 10 or 12, ready for the final cardboard box. An automated cartoning machine erects the flat cardboard boxes, folding the flaps and preparing them for filling. A robotic arm pushes the stack of pads into the open box, ensuring a perfect, tight fit. The box flaps are glued shut, and a batch code is printed on the side for traceability. Workers pack the individual retail boxes into large corrugated shipping cases for transport to distribution centers globally. Pallets are stacked high with the finished product, wrapped in plastic to keep them stable and clean. Forklifts move the pallets to the warehouse, where they await shipment to supermarkets, pharmacies, and aid organizations.
This factory also focuses on the social impact of its operations, employing local women from rural areas.
By providing jobs, the factory empowers the community while producing a product that supports women's health globally.
We also provide free sanitary pads to local schools, helping keep girls in education during their cycles.
The water used in the factory is treated in an on-site plant and recycled for garden irrigation. Solar panels on the roof provide 50% of the energy required to run the heavy machinery. Even the banana pulp waste is converted into biogas, which powers the cafeteria kitchen for the workers. Every aspect of this production is designed to be circular, minimizing waste and maximizing environmental positive impact.
The banana stem, once considered a burden to farmers, has become a valuable commodity in this region.
Farmers now earn extra income by selling their stems, improving their livelihoods, and reducing agricultural waste burning.
Consumers who choose these pads are directly reducing the amount of plastic waste entering our oceans daily.
The texture of the banana fiber is naturally breathable, reducing the risk of rashes and skin infections. It is a perfect example of how nature provides the best solutions for our modern hygiene needs.
As we look at the finished product, it is hard to believe it started as a stem.
Innovation and engineering have turned a simple plant into a sophisticated, medical-grade hygiene tool for women everywhere.
This model of manufacturing can be replicated in tropical regions around the world where bananas are grown.
It represents a shift towards a bioeconomy, where we use renewable resources instead of finite fossil fuels.
The journey from farm to factory to shelf is a testament to human ingenuity and environmental stewardship.
We hope this process inspires more industries to look for sustainable alternatives in their own raw materials.
Thank you for joining us inside this incredible facility and witnessing the future of eco-friendly hygiene manufacturing.
Please subscribe to our channel for more documentaries on how sustainable technology is changing our world today.